everyone, welcome back to Trigonometry. Today we're in section 4.2, where we're going to continue looking at techniques for graphing the sine and cosine functions. Now in the last section we talked about graphing changes to amplitude and period. In this section we will talk about horizontal translations, also called phase shift, which is just moving the graph to the left or right without stretching it, and vertical translation, which is just moving the graph up or down without stretching it. And we will also do several examples where we have a combination of translations. In other words, we'll have changes to either amplitude, period, phase shift, or vertical shift, or a combination of any of those. So we've got plenty to do today, so let's get started. So first, let's talk about horizontal translations. Like I said before, a horizontal translation moves a function's graph to the left or right without stretching or shrinking it. And the name for the horizontal translation of a periodic function is called a phase shift. So instead of actually using the words horizontal translation, we will routinely talk about phase shift when we want to talk about moving the graph of sine or cosine to the left or to the right. Now, as you remember in section 4.1, where we had no phase shift, our patterns always started at x equals 0. So because we had no phase shift, our graphs always started at the y-axis. Now that we have a phase shift, that means that the start of the pattern will be shifted either to the left or the right of the y-axis, so our initial tick mark will not go at the origin whenever we have a phase shift. And now we're not going to want to write the words phase shift over and over again. So although it's not used in MyLab, the normal abbreviation for phase shift is this Greek letter phi. Now I know that you might have seen this letter elsewhere pronounced as phi. A lot of times when it's used in the name of a club, like Phi Theta Kappa, they pronounce it as phi. But in mathematics, it's always pronounced phi, and this happens to be lowercase phi. And we use this letter because the pH in phi stands in for the pH in phase shift. So before we start drawing our own graphs with phase shift, let's look at a graph that involves a phase shift. So here we have the graph of y equals the sine of parentheses x minus pi over 4. Now because this is a sine function, we know that the pattern should be middle, high, middle, low, middle. So when we come over here to the graph, notice that the middle, high, middle, low, middle pattern has been shifted away from the origin. In fact, that pattern starts at pi over 4. And I know that's pi over 4 because even though it was not labeled on the original graph, we have 0 here and pi over 2 here. So halfway in between them must be pi over 4. Okay, so here is the start of the sine pattern. And so the function y equals sine of parentheses x minus pi over 4 is just the graph of sine of x, but it's been shifted pi over 4 radians to the right of the axis. And therefore we would say that the phase shift, or phi, is pi over 4. And when you see it written this way, you know that the phase shift is to the right because the number is positive, and a positive horizontal value means we're moving to the right. Now on the other hand, here is the graph of y equals the sine of parentheses x plus pi over 4. Okay, now look at this graph, and you can see that the middle, high, middle, low, middle pattern begins to the left of the y-axis. And in fact, it starts at negative pi over 4. So in this case, we would say that sine of x plus pi over 4 is just the graph of sine of x, but it's been shifted pi over 4 radians, this time to the left. And so when we want to give a value for phi, because this phase shift is to the left, we'll say that phi equals negative pi over 4. Now here we have just the same two graphs we saw on the previous slide, and you can see from the two graphs above that the phase shift tells us where we can find the start of a pattern for one cycle of the function. And after that first cycle is graphed, then we can graph more cycles either to the right or to the left of that initial cycle. In this class, we will always graph more cycles to the right. Now, what happens if you have a number other than 1 in the b position? Well, in the function y equals the sine of bx minus d, the numbers b and d both will affect phase shift. So to calculate the phase shift, what you'll do is set the entire argument of the trig function equal to 0. Now, by argument, I mean whatever is being plugged into the trig function. So when there's a phase shift, that always involves parentheses. So basically you can think of it as you're going to set everything in parentheses equal to 0 and solve that equation for x. Whatever you get for x will be your phi, or your phase shift. So when phi comes out positive, we can say that the starting point is shifted phi radians to the right. And when phi comes out negative, then we can say that the starting point is shifted phi radians to the left. Now this phase shift is going to affect our horizontal axis labels for the end of each cycle as well. Because the starting point of each cycle has been shifted phi radians to the left or to the right, the horizontal axis labels for end of cycle will also be shifted phi radians in the same direction. This is really not a problem, but remember how we always calculated the end of cycle labels in the previous section. We always said that we found the label for the end of the cycle by calculating starting point plus period, and that gave us the ending point. And we will still do that in this section. It's just that now the starting point for our first cycle will no longer be 0. Now the starting point for the first cycle is whatever we calculated as phi. So let's practice just a little bit before we start graphing our own functions. Let's practice calculating the labels that go at the beginning of the first cycle, the end of the first cycle, and the end of the second cycle. So here we have the graph of y equals the sine of x minus pi over 3. And first it says calculate the phase shift, which will be the label for point A. Okay, so we know that in order to calculate phase shift, we take whatever's in the parentheses and we set it equal to 0. So first write your little equation there, and then you want to isolate the variable, which is x. So in this case, we would just add pi over 3 to both sides, and we would come up with x equals pi over 3. And so that tells us that the phase shift is pi over 3, and therefore the label for the beginning of that first cycle is also pi over 3. Now, to figure out the label for point B, we know that we have to say starting point plus period, and that equals the ending point. So we'll need to know the period for this graph. Now we know that period is 2 pi over b, and in this case the b number is 1. So in this case the period is 2 pi over 1, which of course simplifies to 2 pi. So now to calculate point B, we're going to say starting point plus period equals ending point. So that would be pi over 3 plus 2 pi, and that would be our ending point, but notice that here we have a fraction plus a whole number. Now, we know that whenever we add fractions, we must have a common denominator. So this first denominator is 3, and for 2 pi, the denominator is 1. So we'll need to create a common denominator. So what we'll do is we'll multiply this 2 pi by 3 over 3. That will give us the common denominator that we want. And so now we're adding pi over 3 plus 6 pi over 3, because 2 pi times 3 is 6 pi. And so we have pi over 3 plus 6 pi over 3, and we add the numerators, and that adds up to 7 pi over 3. And so that's our label for the end of the first period. Now to get from point B to point C, we would need to travel another 2 pi. So the label that goes at the end of the second period is going to be, again, starting place, which this time is 7 pi over 3, plus period, which we know is 2 pi, but we also know we're going to need to have a common denominator. So let's go ahead and put the 6 pi over 3 there. And now 7 pi over 3 plus 6 pi over 3 is going to be 13 pi over 3, and that will be the label for the end of the second period. Now honestly, working with fractions like this should not be a problem for you because you are in college and you are in trigonometry. So you should know how to add fractions. But you do have your TI-30X2S calculator, which handles fractions as well. So let's look at how to add these fractions on your calculator. So whenever you want the calculator to add 2 radian measures for you, what you'll do is just enter the numbers in your calculator but without the pi symbol. Because remember, we want to stay in exact form. And if you call in the pi symbol on the calculator, it's going to convert it to decimal form for you. You do not want that. So what we'll be doing is adding just 1/3 plus 2 on the calculator. So you're going to enter 1 fraction 3 plus 2. And when you hit equal, now this is more than 1, so it gives it to you first as a mixed number, and you have to know that that should be converted to an improper fraction. And you can do that yourself, or you can have the calculator do it. You remember this from section 3.1 by using the mixed number to improper fraction function right here. It's the second function of your fraction button. So second fraction button equals, and there is our improper fraction, 7/3. And so now we know that pi over 3 plus 2 pi is 7 pi over 3. See, we know the pi is there, but we don't ask the calculator to handle it for us. And now we are ready to try drawing our own phase-shifted graphs. So here in example 2, it says graph y equals the cosine of parentheses x minus pi over 6 over an interval of 2 periods. Now we're going to approach all the functions in this section the same way we did the functions in the previous section. First, we pull out the numbers that are given to us in the function, and then we figure out what effect those numbers are having on the graph. And then, last of all, we graph and we make sure that we label our axes. Okay, so starting at the beginning, what number is in the A position? Well, we know the number in the A position is the coefficient of the trig function, so our A number is 1. Our B number is the coefficient of the variable, so again, B is 1. And then D is whatever's being subtracted from the x term in the argument. So if we have here x minus D, then D is pi over 6. Okay, now we know that the amplitude is the absolute value of A. So it looks like amplitude is 1. And because A is positive, there is no flip. And that means that the pattern will be just our basic cosine pattern, which is high, middle, low, middle, high. Now the period we know is 2 pi over B. So that's going to be just 2 pi. And now because we have a number in the D position, we know there's going to be a phase shift. And you know that the way to calculate phase shift is to take whatever's in the parentheses and set it equal to 0. Okay, this one's easy to solve. So all we have to do is add pi over 6 to both sides, and we end up with x equals positive pi over 6. That means our phase shift, phi, is positive pi over 6. And in words, that means that the phase shift is pi over 6 radians to the right. Now let's go ahead and calculate the labels that go on the horizontal axis at the end of each cycle. So if our first cycle starts at pi over 6, and then we travel 2 pi radians, then to find the ending label, we'll have to say pi over 6 plus 2 pi. Now, of course, we need a common denominator here. We need the denominator to be 6. So we multiply that 2 pi term by 6 over 6, and then we have pi over 6 plus 12 pi over 6. And of course, that is 13 pi over 6. Now for the second cycle, we're starting at 13 pi over 6, and we're adding another period to that. So we're adding another 2 pi, but we already know that with the common denominator in place, we're adding 12 pi over 6. And now 13 pi over 6 plus 12 pi over 6 is 25 pi over 6. Okay, now everything's in place. Let's go ahead and start labeling the vertical and horizontal axis on our coordinate system. So we know the amplitude is 1. So on the vertical axis, we'll have positive 1 and negative 1. And now we know phase shift is pi over 6 radians to the right. So my first tick mark will not be at the origin like it always has been. It will be shifted a little bit to the right. Now you might at first be wondering how far to the right. Well, pi over 6 is pretty small, so not much, but just go a little bit to the right. We're not really graphing a technically perfect graph. We're kind of sketching the graph. So it's really just a judgment call how far we shift over to the right. Just shift over a little bit and call that pi over 6. And now the next thing is to lay out the 4 tick marks that our first cycle will fit on. So 1, 2, 3, 4. That is going to be the end of the first period. So the label that goes there is 13 pi over 6. And then we'll lay out the 4 tick marks for our second period. And at the end of the second period, the label should be 25 pi over 6. Okay, now let's sketch the dots for our pattern. So we know that the pattern is high, middle, low, high. It's going to start at pi over 6 at the high point. So here we go, high, middle, low, high. You see how my first dot is not on the axis, it's shifted over. That's the phase shift. So we've got high, middle, low, high, and then you're just going to continue that pattern for the second cycle. And now we're ready to connect the dots. Now whenever you have a phase shift and you're ready to start connecting the dots, always start at the first dot. Do not go back to the axis. At least in this class, we will want you to draw exactly the number of periods required in the instructions. And since it says draw exactly 2 periods, we want to start at the beginning of the first period and then end at the end of the second period. We do not want to extend back to the axis, although it is possible to do that, and you will see that in my lab, and you may even see it on a test. But when you are drawing graphs for a grade in this class, always start connecting your dots at the first dot. So we're going to come out a little bit from this dot. You know how we do the hilltops and valleys. So come out a little bit and then slope down. And then slope down to the low point and back up. And you know how it looks. Just finish your pattern like that. Okay, there we have 2 complete periods for the graph of cosine of x minus pi over 6. High, middle, high. And then again, high, middle, high for the second period. Now, when you have a function that looks like a times the sine of x minus d, of course your b number in that case is 1. So it's easy to mentally calculate phase shift without actually writing down the equation and solving it. You can think in your head x minus d equals 0 and know that when you solve it, x will equal d. But keep in mind that when the b number is something other than 1, the b number is going to affect the phase shift. So we calculate phase shift by setting the whole argument equal to 0 before solving for x. In other words, we write down the whole inside of the parentheses and then put equals 0 after that. That's what we have to solve. So in the case of a times the sine of bx minus d, we would have to solve the equation bx minus d equals 0. So you see your b number is going to have an effect on your phase shift. So here in example 3, let's graph y equals the sine of 4x minus pi over an interval of 2 periods. And again, as always, we start by pulling out the numbers given in the problem. So in this case, the a number is 1. A is the coefficient of the sine function. The b number here is going to be 4. That's the coefficient of the variable. And the d number is whatever's being subtracted from the x term. So if this is bx minus d, then the D number is pi. Okay, so what does all of that mean for our graph? Well, we know that the amplitude will be 1, and because A is positive, there will be no flip. We know that the pattern is the basic sine pattern, so it's going to be middle, high, middle, low, middle. And then for the period, we know that period is 2 pi over B, so that's going to be 2 pi over 4, and that's going to reduce to just pi over 2. So our period will be pi over 2. Now, because we have a number in the D position, we know that there will be a phase shift. So to calculate phase shift, we take the whole inside of the parentheses and set it equal to 0. Now when we solve this, we'll add pi to both sides, and then we'll have 4x equals pi. And then to isolate the variable, we'll divide both sides by 4, and x will equal pi over 4. That means that phi, our phase shift, is pi over 4, and in words we would say that the phase shift is pi over 4 radians to the right, because we had a positive number for phase shift. Now let's go ahead and calculate the horizontal axis labels for the end of each cycle. We know that we do that by calculating starting point plus period, and that gives us our ending point. So the starting point for the first cycle is, of course, your phase shift. So we'll have pi over 4, then plus a period means we're going to be adding pi over 2 to that. But of course, we need a common denominator here. So we'll multiply pi over 2 by 2 over 2, and that will give us pi over 4 plus 2 pi over 4, which adds up to 3 pi over 4. So that's the end of the first cycle. Now for the second cycle, so the second cycle starts at 3 pi over 4. When we add a period to that, that means we'll add 2 pi over 4 to that, and that will give us an ending position of 5 pi over 4. Okay, now we're ready to set up our axes. On the vertical axis, we know that amplitude is 1, so we'll have positive 1 and negative 1 on the vertical axis. On the horizontal axis, we know that the initial mark for the first period needs to go at pi over 4, so that's positive, so that's going to be to the right of the y-axis. That's why we say the phase shift is pi over 4 to the right. Okay, so I just will put myself a mark a little bit to the right of the y-axis, and I'll call that pi over 4. Now to get the rest of the tick marks for the first cycle, I'll just go 1, 2, 3, 4. And those are pretty evenly spaced. Just do your best to space them out evenly. And then that fourth tick mark will be the end of your first period, so we know that that's 3 pi over 4. And then for the second period, lay out your next 4 tick marks, still spaced the same as the first 4. And then the end of that second period, we've already calculated, will be 5 pi over 4. Okay, now let's think about our pattern. It's a sine pattern, so we know it's middle, high, middle, low, middle. And so we start right here. Middle, high, middle, low, middle. And then you repeat that same pattern for the second cycle. And now when we connect the dots, we just make our hilltops and valleys like normal. So gently up to the high point and gently down to the low point. And there you go, 2 complete cycles of the graph of y equals sine of 4x minus pi. Now so far in this section, every graph that we've drawn has had a phase shift to the right. And whenever you have a phase shift to the right, that's easier than a phase shift to the left, because when your phase shift, phi, is positive, then the phase shift is to the right, and that means that the y-axis is to the left of your graph. So the y-axis is, so to speak, behind you, and that means we can space out the tick marks however we like, and no extra calculations are necessary. But when your phase shift is negative, that means phase shift is to the left, and that means when you're laying out your 4 tick marks, you're going to have to cross the y-axis. So at that point, the y-axis is kind of in your way. That means we need to figure out which tick marks belong to the left of the y-axis. In other words, we will need to find the location of any tick marks that are negative. because those will be to the left of the y-axis. It's an extra step, and it's kind of a pain in the neck, but it's nothing we can't handle. And we only will have to do this when we have a phase shift to the left. Now, once we have found a tick mark that's either on the y-axis or to the right of the y-axis, then we can carry on as before. So how do we calculate tick marks? Whenever we lay out our 4 tick marks for one pattern, each tick mark represents a quarter of the period from the previous tick mark. So to calculate the location of the next tick mark, we take the location of the first tick mark and we add a quarter of the period, and that gives us the location of the next quarter tick mark. So we definitely need an example for this. Here we have example 4. It says graph y equals 3 times the cosine of x plus pi over 4 over an interval of 2 periods. So as always, let's get our numbers first. In this case, A is 3. Our B number is 1. And look what happened here. We have x plus pi over 4. Now you remember that the form of the graph is y equals A times the cosine of bx minus d. But here we have a plus sign instead of a minus sign. And what that means is d is actually negative. So I'm going to put here that d equals negative pi over 4. I don't want you to worry too much about that sign because it really all comes out in the wash when we solve the equation. But the reason we say this is negative is that the formula is cosine of bx minus d. So to account for the plus sign here, we have to think of this as x minus something. And if it's x plus pi over 4, then it's x minus negative pi over 4, you see. Okay, now carrying on. Amplitude we know is going to be 3 with no flip. This is a cosine graph with no flip, so the pattern will be high, middle, low, middle, high. And the period is 2 pi over b, but b is 1. So 2 pi over 1 is just 2 pi. Now to calculate phase shift, we take what's in parentheses, x plus pi over 4, and we say that's equal to 0. So when we solve this, we come out with x equals negative pi over 4. That means our phase shift is negative pi over 4. And in words, that means that the phase shift is pi over 4 radians to the left. Now notice that I did not say that it was negative pi over 4 radians to the left, because the purpose of the negative is to indicate direction. Whenever we state the phase shift in words, we always use a positive number, and then we state whether the direction is to the left or the right. But when we're stating it as phi, in other words, we're stating it as a number, then we don't have the word left or the word right. And in that case, the direction is indicated by the sign here. So I hope you see the difference. Whenever we say it in words, we will always have a positive number and then followed by the words to the left or to the right. Okay, now let's calculate the labels that are going to go at the end of the first cycle and the end of the second cycle. So we know that we do that by saying starting point plus period equals ending point. Our starting point for the first cycle is our phase shift. So here we will have negative pi over 4 plus a period, so plus 2 pi, and that's going to give us our ending point. Now we need a common denominator, and that's going to be 4. So let me multiply this 2 pi by 4 over 4. That's going to give us negative pi over 4 plus 8 pi over 4, which will add up to 7 pi over 4. And then for the second cycle, we start at 7 pi over 4. We add another 2 pi to that, but with our common denominator, we're going to write plus 8 pi over 4. And that's going to add up to 15 pi over 4. Okay, now here is the part we haven't seen before. We know that when we place our initial tick mark on the horizontal axis, that first tick mark is going to go at the phase shift, which is negative pi over 4. But what we don't know is where the next 4 tick marks should be placed in relation to the axis. So we don't know if we should go 1, 2, 3, 4 like that, or maybe 1, 2, 3, 4 like that, or maybe it's 1, 2, 3, 4. You see, we don't know whether these tick marks should be to the left or the right of the axis until we calculate their location. So what we have to do is start with our phase shift and add a quarter of a period at a time until we hit a tick mark that's either 0 or more than 0, and then we can stop. So first, before we start doing this, let's calculate what a quarter of a period is. Well, we know the period is 2 pi, so a quarter of a period is going to be a quarter of 2 pi. And when you multiply 1/4 times 2 pi, you get 2 pi over 4. Now, I know that can be reduced, but my tip to you is don't reduce it, because usually if you reduce it, all you're doing is just losing your common denominator and you have to then get it back. So just leave this unsimplified. It's probably fine. So now let's calculate the location of the first tick mark. We know that the starting mark is at negative pi over 4. And if we go a quarter of a period from that, then negative pi over 4 plus 2 pi over 4 is 1 pi over 4. Okay, now I know that the first quarter tick mark is positive, so it's going to be to the right of the y-axis. So now we know that the only tick mark we'll have to the left of the y-axis is just this initial one. When we draw our next 4 tick marks, the first one goes actually to the right of the y-axis. Okay, so I had to make a new page so that I could have room to draw the graph, but what I've done is I've copied over here all the information that we already had figured out. So let's start by labeling our vertical axis. We know the amplitude is 3, so we have positive 3 and negative 3 on the vertical axis. On the horizontal axis, the initial tick mark is the phase shift. So the initial tick mark is going to be to the left of the y-axis. So let's come just a little bit to the left of the axis and put our initial tick mark there, and we'll label that negative pi over 4. Now the next 4 tick marks are going to start at positive pi over 4. So that's going to be the same distance to the right of the axis as our initial mark was to the left of the axis. So I'm going to come right here and I'm going to label that positive pi over 4. Now, you know, we always did an initial mark and then 4 more marks. And so this is the first of our 4 more marks. And because it's positive, I can just space the others evenly. So notice how far these first 2 are apart. The rest of them should be the same distance apart. So 2, 3, 4, and that's going to be the end of the first period, and so that label will be 7 pi over 4. And then 1, 2, 3, 4, that's going to be the end of the second period, so that label is going to be 15 pi over 4. And now let's place our dots. So the pattern was high, middle, high. We'll come right here to the phase shift, and that's where we'll put a dot at the high point. So high, middle, low, middle, high. And then repeat that for the second period. And now we're ready to connect the dots. So starting with the first dot, we know that we come out a little and then gently down. And then we go gently down, you know, hilltops and valleys like we always say. And here we have 2 periods of the graph of y equals 3 cosine of x plus pi over 4. Now here is example 5, and this time we're graphing 2 periods of y equals negative 2 sine of 3x plus pi. So let's pick out our a, b, and d numbers. A this time is negative 2, b is 3, and d is negative pi. And whenever you see that negative d number, that's a clue to you that your phase shift is going to be to the left. You already can know. All right, now amplitude we know is the absolute value of a. So amplitude is 2 here. And because of the negative on our a value, we do have a flip. Now this is a sine pattern, so normally it would be middle, high, middle, low, middle, but it's flipped over, so it's going to be middle, low, middle, high, middle. Okay, period is 2 pi over b, and in this case b is 3, so period is going to be 2 pi over 3. Now let's calculate phase shift. Remember that we have to put the whole parentheses equal to 0. We just can't say that the D number is the phase shift. We have the whole parentheses equal to 0, and when we solve that, we get 3x equals negative pi, and then when you divide both sides by 3, you get x equals negative pi over 3, and that means your phase shift is negative pi over 3. And so, of course, the negative means we're moving to the left. So in words, our phase shift is pi over 3 radians to the left. Okay, now let's get the horizontal axis labels for the end of each cycle. And you know that we do that by calculating starting point plus period equals ending point. So starting point for the first cycle is the phase shift. So that's going to be negative pi over 3. And when we add a period to that, we're going to be adding 2 pi over 3. Luckily, we already have a common denominator here. So negative 1 pi over 3 plus 2 pi over 3 puts the end of the first cycle at pi over 3. For the second cycle, we start at pi over 3, we add another period to that, and 1 pi over 3 plus 2 pi over 3 is 3 pi over 3, which we know will reduce to just pi. Okay, so now we've got the labels that go at the end of each cycle. Because our initial tick mark for the first cycle is to the left of the y-axis, and that first cycle ends to the right of the y-axis, we need to think about which tick marks go to the left and to the right of the axis. So we'll need to calculate the location of at least some of the quarter tick marks for that first period. So we know that in order to calculate the location of the quarter tick marks, we add a quarter of the period at a time. So a quarter of the period would be a fourth of 2 pi over 3. And when you multiply those two together, 1/4 times 2 pi over 3 is 2 pi over 12. So remember, our strategy is to start at the beginning of the first period, which is at negative pi over 3, and add a quarter of a period to that, and we keep adding a quarter of a period until we get something positive, so that we know which tick marks go to the left of the y-axis and which tick marks go to the right of the y-axis. So let's start here with negative pi over 3 plus a quarter of the period. Now, I know that this could be reduced, but it would reduce to pi over 6, and I would still have to get a common denominator here because I would have a 3 and a 6. So there's really no use for me to reduce it right now. So what I'm going to do is get a common denominator here for the 3 and the 12. I know that 3 times 4 is 12. So if I multiply this fraction by 4 over 4, then I'll have negative 4 pi over 12 plus 2 pi over 12. Together, those add up to negative 2 pi over 12. So our first quarter tick mark after our initial mark, the first quarter tick mark goes at negative 2 pi over 12. So it's still to the left of the y-axis. So that means we have to calculate a second tick mark. And if we now go negative 2 pi over 12 plus another quarter of a period, so plus another 2 pi over 12, that puts us at 0. So the first of our 4 marks after the initial mark goes to the left of the y-axis, but the second one goes exactly on the y-axis. So now let's take all of this information to the next slide. So all of this is what we already had figured out, and now let's see if we can graph with it. Okay, so we know amplitude is 2, so we're going to need to have marks of positive 2 and negative 2 on our vertical axis. Now the next thing is our horizontal marks. So we know that the phase shift is negative pi over 3. So the initial mark for our first period goes to the left of the y-axis, and we know there's another tick mark that also goes to the left of the axis. So I'm going to put the first one here, that's negative pi over 3. Now when I lay out the next 4, I'm going to put the first one to the left of the y-axis, and that will be negative pi over 6. The second one goes exactly on the y-axis, and then the last 2, I don't care about the label for the next quarter tick mark, and then the last one will be the end of the first cycle. So look what I've got here. My starting mark plus 4 more tick marks. The first quarter tick mark is to the left of the y-axis. The second one is exactly on the axis. And then the last two are just evenly spaced from the first two. But the last one right here happens to be the end of the first cycle. So we already know the label that goes there is positive pi over 3. And now for the next cycle, we lay out 4 more tick marks. And that last mark there will be the end of the second cycle. So we already know that's pi. Now to put in the dots, we know that the pattern is middle, low, middle, high, middle. And we know that we're starting back here at the phase shift. So we're going to have a dot here, middle, then low, middle, high, middle. And then repeat that for the second pattern. And then connect your dots with that nice sine curve shape that we're used to by now. Okay, this one was a little more work, but it was really the phase shift to the left that caused a little more work than usual. I do want to point out here a shortcut that can work sometimes. So I just will point out to you that if you have calculated your phase shift and it's to the left, and then you calculate the end of the first cycle and it is the same amount to the right, notice how my phase shift was negative pi over 3 and the end of the first cycle was at positive pi over 3. Because these two numbers are opposites of each other, it means that the middle of the pattern has to go right at 0. And if the middle of the pattern is at 0, then you can space the first tick mark halfway between the beginning and the axis, and you can space the third tick mark halfway between the axis and the end of that period. If that's not clicking for you, don't worry about it at all. It's fine. You can just always calculate the location of the tick marks. But I just think it's nice if you can notice that little shortcut, you can take it and it'll save you the couple of minutes that it takes to calculate those quarter tick marks. Now let's talk about what happens when your argument is in a factored form. So it would look like b times x minus d in brackets rather than just bx minus d in parentheses. In this case, the b will divide out when you calculate phase shift. And because that b divides out, factored form allows you to ignore b when calculating phase shift. Let's see for ourselves. So suppose we were asked to graph a function that looked like this, and we're ready to calculate phase shift. So we would take what's in the brackets and set it equal to 0 like you see here. And the very first thing you would do to try to isolate the x is divide both sides by whatever number is in the b position. So if we divide both sides by b, it cancels out from the left side, but the right side will be 0 divided by that b number, which is still just going to be 0. So that leaves us with x minus d equals 0. And then when you add d to both sides, you can see that the phase shift is d. And the b has nothing to do with the phase shift in this case because it divided out in the first step. So we can say that if the argument is in factored form, then phi will equal whatever number is in the d position. But b still will have an effect on your graph because the period still equals 2 pi over b as it always has. So here is example 6. So we're going to graph together y equals 3 times the cosine of bracket pi over 2 times x minus 1/2. And we're going to graph 2 periods of that. So first let's pull out the numbers given in the function. The a number is 3, the b number is pi over 2, and the d number is 1/2 because we have x minus d. So that means that d is 1/2. Now, since a is 3, the amplitude is 3, and we know that there's no flip involved here. The pattern of the cosine graph would be high, middle, low, middle, high. And the period will be 2 pi over b. So that's going to be 2 pi over 2. So, of course, when dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. So we have 2 pi times 2 over pi. In this case, the pi's cancel because we have a top-bottom pair, and then 2 times 2 is 4. So the period here is 4. Now we do have a number in the D position, so let's calculate phase shift. We know that because the B has been factored out, it will not affect the phase shift. So we can just say x minus 1/2 equals 0, which means that x equals 1/2, and therefore the phase shift is positive 1/2. In words, that means that the phase shift is 1/2 unit to the right. Now let's get the labels for the end of each cycle. So the starting point for the first cycle will be the phase shift, so that's 1/2, plus the period, which in this case is 4. Now 1/2 plus 4 is 4.5. Now if pi were involved here, we would not be able to leave this number in mixed number form, but for our purposes, for this example, it's fine to leave this in mixed number form. It works well here because it's just a label on the horizontal axis. And now for the label at the end of the second cycle, we'll take our starting point, which is the 4.5, and we'll add another period to that, which is 4, and then 4.5 plus 4 gives us 8.5. And again, we'll just leave that in mixed number form. Now because we had a phase shift to the right, we did not need to calculate the location of any of the tick marks because none of them were going to be to the left of the y-axis. And now I've copied all of the information from the first slide over here, and we're ready to graph. So let's start by labeling our vertical axis with a +3 and a -3. And then the next thing is our horizontal axis. So we'll move over to the right just a little bit and label our phase shift as 1/2. And then we want to go 1, 2, 3, 4. That mark is the end of the first period, so that one's going to be 4.5. And then 1, 2, 3, 4 again, and the end of the second period, of course, is 8.5. And then our pattern we know is high, middle, low, middle, high. So right here, starting at the phase shift, we'll put a dot at high, then middle, low, middle, high, and repeat that for the second pattern, and then connect the dots smoothly in that nice cosine shape. Now we're ready to talk about vertical translations of the graphs of sine and cosine. So let's start by just thinking about a generic function like f of x. If you know what the graph of f of x looks like, then c plus f of x will have the same shape, but it will be translated vertically compared to the original graph of f of x. The translation will be c units up if c is positive, or c units down if c is negative. And here you can see a graph that's been translated vertically. So compared to the original graph, everything's moved up. Let's look at this a little more closely. The equation for this dotted curve is y equals 2 sine of x, and you can see here that the amplitude is 2. Now if you compare the solid curve to the dotted curve, what started out at y equals 0 ends up at y equals 5. So it's just been moved up 5 units. And we could say the same thing for the high point on the original graph. The high point on the original graph was 2, and the high point on the translated graph is at 7. So all the way across the whole graph, every y value from the original function has been moved up 5 units. And that means we can represent the solid curve by saying y equals 5 plus 2 times the sine of x. So notice that for the original function, which is the dotted function, the high point was at y equals 2, the middle point was at y equals 0, and the low point was at -2. And this is what we've seen for every graph that we've graphed up to this point. Whatever the amplitude was, that determined the high and the low of the graph, and the middle was always at 0, right? Well, now that we are vertically translating the graph, each of these points will have 5 added to it. And so now, with everything translated up 5 units, the high point of the new graph will be 7, the middle will be 5, and the low point will be 3, because -2 plus 5 is 3. When we draw our own graphs that have been translated vertically, we will use dotted horizontal lines to show the vertical translation and help us remember where the graph belongs. So before we sketch our graphs, what we will do is put a dotted line to represent the high, middle, and low points on the graph, and then we'll plot the dots that we're used to plotting so that we can connect the dots and see the graph. So let's look together at example 7, and we're asked to graph y equals 4 minus 2 cosine of 3x over 2 over an interval of 2 periods. We'll start the way we always do by pulling out the given numbers. You can see here that a is negative 2, b is 3 over 2, and there's nothing subtracted from the x term of our argument, so that means d is 0, which of course means there will be no phase shift. And then c is going to be positive 4. So what does this mean for our graph? Well, the amplitude will be 2, and there will be a flip because a is negative. The pattern is going to be a flipped cosine pattern, so low, middle, high, middle, low. And then the period is 2 pi over b, so that's going to be 2 pi over 3/2, which is the same as 2 pi times the reciprocal of 3/2, and that's going to give us 4 pi over 3. Now, where it says calculate phase shift, there's not a phase shift because there's no number in the d position, so we can say that there's no phase shift. You can go ahead and fill in these blanks down here as phi equals 0, and so there's nothing to put in words. Now, to calculate the labels that go on the horizontal axis at the end of each period, we know that we do that by saying starting point plus period equals ending point. In this case, the starting point is 0, the period is 4 pi over 3, and so the ending point will be 0 plus 4 pi over 3, so that's just 4 pi over 3. The second period will start at 4 pi over 3, and then when we add a period to that, we'll get 8 pi over 3. So that's the label for the end of the second period. Now let's think about vertical shift. We know c is 4, so the vertical shift will be 4 units up because c was positive. Now, to calculate the vertical axis labels, we'll start with what the high, middle, and low would have been without c. In this case, amplitude was 2. So the high, middle, low would have been 2, 0, and negative 2. But if we add 4 to each one of those, we can see that the new high is going to be 2 plus 4, which is 6. The new middle will be 0 plus 4, which is 4. And the new low will be negative 2 plus 4, which is 2. Now let me copy all of this onto the next slide, and we're ready to graph. So like we always do, we'll start with our vertical axis, and we can see that the high point on the vertical axis is going to be 6, and the low point is going to be 2. So let's go 1, 2, 3, 4, 5, 6. That highest tick mark is at 6. The 2 would be right here, and halfway in between those two would be the 4. Now, in order to keep everything straight, we'll want to put horizontal dotted lines at each of those points, and that's going to help us remember that our pattern stays within these dotted lines. Okay, now the labels for the horizontal axis. So we know that our initial mark goes at 0, so at the origin. And by the way, we're going to keep our tick marks for the horizontal axis on the axis. A lot of students are tempted to move the labels up to the lowest dotted line. We really should not do that. It's always the axes that are labeled. So our initial tick mark for the first period we have put at the origin, and then we're going to go 1, 2, 3, 4. Now that's the end of the first period, so that gets the label 4 pi over 3. And then we need to go 1, 2, 3, 4 again for the second period, and that label will be 8 pi over 3. And now we're ready to put the dots. So we remember that the pattern was low, middle, high, middle, low. And starting right here, we're going to place a dot in the low position, which is at 2 on the y-axis. So low, middle, high, middle, low. And then repeat that for the second period, and then smoothly connect the dots in that cosine shape that we're used to. Doing the vertical translation is really not that difficult, but it is an extra step to think about. And the dotted lines really do help because it has become such a habit over the last 2 sections to think about putting our middle dot on the axis. If you don't have these dotted lines to help you stay focused, it's easy for us to get drawn off course. Now here is a similar one. So this is example 8. we're going to graph y equals 1 plus 3 times the sine of 4x over 3 minus pi. And as usual, we're going to graph two periods. So the number in the A position here is 3. The number in the B position is 4/3. And the number in the D position is pi. And the C number is what's been added to the whole thing. So C is out front here, which is positive 1. All right, now the amplitude we know is absolute value of A, so that's 3. And A was positive, so no flip. The pattern is the basic sine pattern, so middle, high, middle, low, middle. And the period will be 2 pi over B, so that's 2 pi over 4/3, which is the same as 2 pi times the reciprocal of 4/3. Now if you notice, we can reduce here because 2 and 4 can both be divided by 2. When we do that, it cancels the 2 out of the top, but it leaves a 2 in the bottom. And so our period ends up being 3 pi over 2. Now we do have a number in the D position, so let's calculate phase shift. We take what's in the parentheses and we set it equal to 0. To solve this for x, we would add pi to both sides, which would give us 4x over 3 equals pi. And then to isolate the x, we would multiply both sides by the reciprocal of 4/3. That cancels the 3 and the 4 from the left side, and it just leaves us with x equals 3 pi over 4. So our phase shift, is 3 pi over 4. And in words, that's 3 pi over 4 to the right. Okay, now let's calculate the labels that go on the horizontal axis. So as always, it's starting point plus period equals ending point. Our starting point for the first cycle is the phase shift. And then we want to add a period to that, so we're adding 3 pi over 2. Of course, we need a common denominator here, so if I multiply this period by 2 over 2, we'll have 3 pi over 4 plus 6 pi over 4, and together that makes 9 pi over 4. So that's the label that goes at the end of the first period. And then for the second period, we start at 9 pi over 4. We add a period to that, which we know with the common denominator that will be 6 pi over 4. And together those two make 15 pi over 4, so that's the label for the end of the second period. Now for vertical shift, we know that C was 1. So that's going to be everything translated 1 in the up direction. Without the vertical shift, just thinking about the amplitude, the high, middle, low would have been 3, 0, negative 3. But if we move everything up 1 unit, the new high will be 3 plus 1, which is 4. The new middle will be 0 plus 1, which is 1. And the new low will be negative 3 plus 1, which is negative 2. Okay, now let me take all of that information to the second slide, and we're ready to start graphing. So let's start with the vertical axis. We need a high point at 4, and then we need our middle point at 1, and then we need our low point at negative 2. And then let's get our dotted horizontal lines, one at the high point, one at the middle point, and one at the low point. Now let's think about our phase shift. So we need to put our initial mark on the horizontal axis at 3 pi over 4. So we'll just move over some amount and call that 3 pi over 4. Now we need to put our 4 tick marks for the first period. So 1, 2, 3, 4. That is going to be the end of the first period. So we'll label that 9 pi over 4. And then 1, 2, 3, 4 more tick marks. That's the end of the second period, so that's 15 pi over 4. And now we're ready to place our dots. We remember that our pattern was middle, high, middle, low, middle, but the middle now goes on this middle dotted line. So at the phase shift, but on the dotted line, we'll put middle, and then high, middle, low, middle. That is the first period. And then we repeat that for the second period, and then just smoothly connect your dots to get a sine curve. And let's do one last graphing example together. This is example 9. We want to graph negative 1 plus 4 times the sine of 3x over 4 plus pi over 2. Let's start by getting the numbers from the function. So the number in the A position is 4. The number in the B position is 3/4. Notice we have a plus sign here, so the number in the D position is actually negative pi over 2. And then the number in the C position is negative 1. Okay, so now we know amplitude is 4, and because A is positive, there's no flip. The pattern will be the basic sign pattern, so middle, high, middle, low, middle. The period will be 2 pi over B, so that's 2 pi over 3/4, which is the same as 2 pi times 4/3, which is 8 pi over 3. So the period is 8 pi over 3. Now we do have a number in the D position, so let's calculate phase shift. Remember, we can't just say that the phase shift is the D number because B affects the phase shift. So we need to take the whole inside of this parentheses and set it equal to 0. And of course we want to isolate the variable, so the first thing we'll do is move this pi over 2 term to the right side. That gives us 3x over 4 equals negative pi over 2. And then we want to eliminate this coefficient of 3/4. So we'll multiply both sides by 4/3. That will cancel out the 4 and the 3 on the left side. And on the right side, the 4 in the top and the 2 in the bottom can be reduced so that it just leaves 2 in the top. And so we end up with x equal to negative 2 pi over 3. And that means that phi is negative 2 pi over 3. In words, that means our phase shift is 2 pi over 3 to the left. Now let's calculate the labels that go at the end of each cycle. Okay, so starting point, which is negative 2 pi over 3 for the first cycle, plus period, which is 8 pi over 3, gives us a total of 6 pi over 3, which we know will reduce to 2 pi. But for purposes of calculating the end of the second cycle, I'm going to leave it unsimplified because I know I'm going to have that common denominator. So for the end of the second cycle, starting point, which is 6 pi over 3, plus period, which is 8 pi over 3, equals 14 pi over 3, and that will be the label that goes at the end of the second cycle. Now, because we had a phase shift to the left, we need to calculate the quarter tick marks, at least any that belong to the left of the y-axis. So how do we do that? We always start at the starting point and add a quarter of a period at a time. So let's start by figuring out what a quarter of a period is. Well, in this case, the period is 8 pi over 3. So a quarter of the period is going to be 1/4 times 8 pi over 3. Now notice that 8 and 4 here can reduce because 4 goes into both of these numbers. So 8 divided by 4 is 2, and in the bottom 4 divided by 4 is 1, so that just disappears. And we're left with a quarter of the period is equal to 2 pi over 3. So that's what we'll add to the starting point to calculate the next tick mark. All right, so now the starting point was negative 2 pi over 3 plus a quarter of the period. Look, those are going to add up to 0. So now we know that the first tick mark goes at 0, which is on the axis. Okay, that's good news. That means we don't have to calculate any more tick marks. For the vertical shift, we know that C is negative 1. So that means that the whole graph is going to get shifted 1 down. Okay, now for the high, middle, low, the amplitude of this graph is 4. So the high, middle, low would have been 4, 0, negative 4. But now everything's going to shift down 1. So we have to say minus 1 on each of those. And 4 minus 1 gives us a new high point of 3. 0 minus 1 gives us a new middle point of negative 1. And negative 4 minus 1 gives us a new low point of negative 5. Let's take all this information to the next slide so we can graph. Let's start like we always do by labeling our vertical axis. So we see that we want to go up to 3 and down to negative 5, and we want to label the negative 1 in the middle. And we also know that we want to put our dotted horizontal lines that show where the graph goes. Okay, now the horizontal axis. We know we have a phase shift to the left of 2 pi over 3. So come left of the axis and put a tick mark some distance out and call that negative 2 pi over 3. And now we're ready to put our 4 tick marks for the first period. And we know that the first of those 4 tick marks goes on the axis. So right there's the first of our 4. Notice how far apart they're spaced. So I need the rest of them to be spaced the same. So there's 1, 2, 3, 4, and that's the end of the first period, so I'll label that 2 pi, and then keeping the spacing the same, 1, 2, 3, 4, and that label at the end of that second period is going to be 14 pi over 3. Okay, now for the pattern. Middle, high, middle, low, middle. But remember that middle now goes on the dotted line, not on the axis. See, if we didn't have that dotted line, you'd be tempted to put that dot on the axis, but it would be wrong. So that's why we have the dotted lines. So back here at the phase shift, our dot goes on the middle dotted line. So middle, then for the next tick mark, high, middle, low, middle. And then repeat that for the second period. Now you're just going to connect the dots as always with that smooth sine curve. And we're finished. You can see our phase shift to the left. You can see our vertical shift down 1 unit from where it would have been. And we can see what the period should be because we can see the labels that go at the end of each cycle. Notice we still have an amplitude of 4. It's still 4 units from the middle to the top. It's just that now everything's been shifted down 1 unit. Okay, now let's talk about choosing multiple choice answers on graphing questions. So when you have to choose the correct graph in a multiple choice situation, the instructions will probably say graph the function, but that's actually not the best approach. The best thing to do instead is to identify the pattern, amplitude, period, phase shift, and vertical shift, and then just eliminate the choices that don't have the right characteristics. Let's look at one together. So this is example 10, and it says graph y equals 1 plus the sine of x plus pi over 3. So the first thing I notice here is that there's a vertical shift of 1. And then the next thing I notice is that we've got a phase shift here. Now b is 1, so the phase shift is just negative pi over 3. And we're looking at a sine function, so the pattern is going to be middle, high, middle, low, middle, but it's going to start at negative pi over 3. Now let's look at our choices and see what we can eliminate. Choice A is showing a graph that's been moved down from the original position, so this one doesn't have the correct vertical shift. Choice B is showing a graph that's not shifted vertically at all, and so that's also not correct. Choice C is showing a graph that's been shifted up 1, but now I need to see if the middle, high, middle, low, middle pattern starts at negative pi over 3. So first, let's look at the horizontal axis and figure out where negative pi over 3 would be. Well, it's not labeled on the axis, but we do see negative 2 pi over 3 right here. And this tick mark is halfway between 0 and negative 2 pi over 3. So this tick mark right here represents negative pi over 3. And now, taking the vertical shift into account, we know that the middle of the pattern should occur right here. So our middle, high, middle, low, middle pattern should start right here at the phase shift, and we would expect the first dot of that pattern to be right there. But as you can see, it's not. So this graph has the correct vertical shift, but not the correct phase shift. So this one's out because the sine pattern does not start at negative pi over 3. So that just leaves D. Let's see if it behaves the way we expect it to. So first we locate the phase shift, which we know is negative pi over 3, which is right here. And then let's remember where the middle of our graph should go. So if the beginning of the sine pattern should start right here at negative pi over 3, we would expect that first dot to go right there, and it does. So notice you can see the beginning of the sine pattern, middle, high, middle, low, and you can't see the rest of it. But we have enough to know that this graph matches the function we were given because it's been shifted up 1, and it also has the pattern starting at the correct place. So that is the correct choice. Now the other type of multiple choice question that you can see is when you're given a graph and asked to identify the correct equation. In this case, the key is going to be to locate the beginning of a pattern on your graph. And then the distance from the y-axis will tell you the phase shift. Keep in mind that while there might be more than one correct answer that exists, only one correct answer will be available as a choice. And it's important to read the instructions because sometimes those will help you cut down on the number of possibilities. So let's look at example 11 together. It says the function graphed is of the form y equals cosine of x minus d or sine of x minus d, where d is the least possible positive value. Determine the equation of the graph. And I want to think about this phrase here, the least possible positive value. What they're telling you is if d is positive, then that means x minus d is going to show a phase shift to the right. So you don't have to worry about what would happen if you shifted to the left. For example, we know that if we look to the left just a little bit, we're finding the beginning of a sine pattern. But they've told us in the instructions up here that we don't have to worry about what would happen if we shifted left. That's not what's going to happen here. So we need to be looking for a pattern that's been shifted some amount to the right. Now, if we come out here to pi over 3, you can see that the graph hits a high point there. So that could be the beginning of a cosine pattern. How would we write the equation of a cosine function that's been shifted pi over 3 units to the right? Well, it would be y equals the cosine of parentheses x minus pi over 3. So let's look at our choices. We do have choice B, which matches that. This is the graph of a cosine function that's been shifted pi over 3 units to the right. So we think this is the right answer, but let's look at the other choices and see what's wrong with them. So in choice A, we have cosine of x minus pi over 3, but there are no parentheses. So in this case, the minus pi over 3 is not acting like a phase shift, it's actually acting like a vertical shift. We know that a phase shifted function will always have its argument in parentheses, and we don't see that here. In choice C, we have the right cosine function, but it's not shifted to the right far enough. You see, if you go out to pi over 6, you don't get the beginning of that high, middle, low, middle, high pattern. So that's the wrong phase shift. And then choice D has the correct phase shift, but not the correct function. Because if we were looking at a sine function that was shifted to the right pi over 3, we would expect this to be the beginning of the middle, high, middle, low, middle pattern. But that's not what we saw. So D is wrong because it's not the right function. Okay, so we have now reached the end of section 4.2 and we have covered a lot of ground here. It is super important for you to practice drawing your own graphs by hand. Remember, MyLab cannot teach you how to graph. It can help you practice the calculations and all of that, but it can't really evaluate graphs that you've drawn because it's software. You need an instructor to look at your graphs and tell you if you're doing them correctly. So if you're in my traditional class, please come to me after class or email me pictures of your graphs so that I can give you some feedback. If you're taking Trig online, then please email pictures of your graphs to your instructor and let them give you some feedback. Either way, this is a super important skill, so I hope that you'll practice, and I'll catch you again in the next section. Bye-bye now.